research, you try something, right? The future could have panned out differently, and it would have been perhaps a different set of people up here. To some extent, we got lucky, but that's the nature of our job in research, is to take risks.
Well, when I did it, I didn't think, but a few years later, I thought, about time, man. It's
and
true.
Then you were waiting for today.
Like, yeah, it took so long. What the heck?
A question can be very different if you are the as far as I'm concerned, the answer is no. I even asked Len at one time, do you think this is publishable?
No.
How do I follow those two? I just remember I was at the Intel lab crawling around the floor with like 50 motes and wires coming off of them, and there was no way I thought that this was important. It was just a lot of manual labor. Yeah, I mean, I think when it flipped for me was working with the biologists at College of the Atlantic, and then we worked with Matt Welsh and his Renador volcano stuff, and then we worked with the Redwoods guys at Berkeley, and so it started to pick up steam, and that's when it's like, oh, there's something here.
Now I can add something. It wasn't Chris Pista the one who said that Faraday lied, so you can go down in the hole and still transmit and see through walls, so you were in that environment.
I don't think we thought these papers would even get in. So the Test of Time award is kind of an amazing surprise. Actually, almost all the RoofNet papers were rejected the first time through, even though the content didn't change that much. So part of it is, the peer review process is a great thing because you get a lot of feedback. We realized that even though the work we'd done hadn't changed, the way we were articulating the ideas and boiling them down to what we thought was significant, could definitely have been improved. So I think all of the papers that came out of the project ended up being better for having been rejected. So I would say we didn't think it would get in, and it actually didn't get in the first time.
So when we started looking at analyzing large wireless networks, the motivation essentially came from people wanting to make everything wireless. And particularly in military, the talk was like we're going to deploy very large-scale wireless networks. So of course, it was a sort of a negative result in the sense that it was showing that something is not feasible to the extent that at least it was anticipated. So we thought it's not going to go very far because it's a negative result. People will see okay and move on. And so it was a big surprise that it was taken up in the way it was. And thank you for the community.
So I would say definitely not at the time. The tip-off, though, came a couple, 2-3 years later when we got invited to come present to the CTOs of Apple, the CTOs of Microsoft, and then it really hit home when the lawyers started asking us to testify as expert witnesses in the various location companies suing each other on the follow-on systems.
Test of time, no. Special, yes, because that was my first paper in a conference and came after a lot of effort. So I thought it was special. My advisor may not think so. I was just thinking if it gets rejected here, what am I going to do next?
But he forgot to mention that we knew something was interesting because in those days, it was pre-Google. There was something called Alta Vista search engine. And we were so narcissistic, we would periodically in the morning put our keyword and see if some of our papers being used in Berkeley and other seminars. So we started getting hits. And then Professor Tannenbaum visited our lab because he wanted to include ITCP in his computer networks textbook. So then we realized, oh wow, this is a free publicity and marketing for our work. And then it took off from there.
So I don't ever remember thinking this could be a test of time paper, but I do remember, so when the paper was first presented, it was at actually an operating systems conference, biannual conference in 1991. And I remember I'd gone to the 89 version and like nobody had laptops, right? But at the 91 conference where we present our paper, almost everybody had laptops and they were busy typing at them, and everybody kind of experienced the reason that we had done this work. And I thought, well, our timing was really, really good. One of us must have done something good in an earlier lifetime, Satya, but you know, the timing was impeccable.
Thank you. I have my own. Cecilia gave me mine. Actually, what Jay has forgotten is on the day of submission of the original paper to SOSP, one of our colleagues at CMU, who shall remain nameless to protect the guilty, wandered in, Jay knows who this is, said, "What are you guys working on?" I said, "Oh, we think we're working on this paper, we're submitting it today." And he quickly skimmed it, and to our face, he said, "This is trash. This isn't going to make it. You know, here's how you should rewrite it," and gave us, you know, something that would have taken us probably 3 weeks to rewrite the whole paper. The deadline was that afternoon, so we sent it in, and it made it, obviously. So, bottom line, don't listen to everything other people tell you.
Yeah. I remember being really demoralized by that talk and how happy I was later that that guy was wrong.
So what I hear here is more, it's unclear what the future will bring for the papers we write. Generally, rejections are not a bad thing. This is mainly for the graduate students. Papers have been rejected, which then went to being very famous. And yes, at some point, when lawyers start talking to you, that's the time when you think, well, maybe I produced something interesting. Is that the message here? Okay, I guess we'll go on to a more detailed question, might bring bigger answer. There have been, on Monday, Suman chaired a workshop on the future of mobile. And they came up with a number of suggestions that could be interesting aspects to be researched in the next few years. And so we are asking really the panel if we have just one more test of time award in 10 years, 2026. What would be, they think, the research that would lead to that now? Of course, they just said they can't predict this, so don't listen to them. In fact, do the opposite, but at least we'll get them talking. And here are some suggestions. I'll leave them up because this work came out from the workshop on Monday, so it might be useful for the community. And I'll ask the panel also to comment on them or to come up with their suggestions, whatever they feel like saying here.
Well, if we're going to do this sequential again, if I were to look at something interesting for the next 10 years, or something to suggest a graduate student even better do over the next 10 years, it would be something involving human interfacing to all the great systems that we have today. One of the things that's impressed me so much is the ease of human input now that you get with voice input. The only way I can send text messages faster than my granddaughter is that I use Siri.
So I'm working in IoT now, as I imagine many people are, because it's a catch-all for everything. But one thing that is holding back a lot of IoT scenarios right now is the networking side of things, right? There's no one network which really does the right thing. Which doesn't need a lot of infrastructure work or doesn't impact the battery life or doesn't, in the case of, for example, Wi-Fi, have a really sucky setup experience. So as a mobile communications community, if we're able to fix that, that will have huge, huge impact.
So I have many things I want to say, but I'll say one thing. This was in vogue several years ago, and I admit that I have also moved on to doing other things, and Sanjeev actually mentioned it in his talk, that there are still many billions of people that are not connected. And so this question or this note behind about spectrum management, this is actually pretty real. If you think about how the FCC had done the allocation, it's multiple decades old way of doing things. And we try to do this with white spaces, try to sort of show that opportunistic networking is possible. There is no real reason to give licensed spectrum if you can have primary, secondary users and things like that. But really, the underlying thing about that is that, and now you see papers between Wi-Fi and LTE-U, and there's a pressure on the systems, in the unlicensed systems, there's pressure from the licensed bodies to sort of grab more and more. But time and again, we have seen that if you leave innovation alone, in the unlicensed band where you can actually do the innovation, you can get a lot out of it, and we have seen that for a fact. And so if you combine all these things about how the spectrum has been allocated, how it's being used, and the fact that there are 4 or 5 billion people that are not connected, I think this is a pretty worthy cause to go in and devote yourself. I actually devoted many, many years of my life on this and pushed it very hard in every possible way I could from where I stood. And now only recently I moved. Not solved, it's not done, it's got to get fixed. So you guys should think about that. And I will try to come back to that also.
Well, I mean, for me, I think of everything that has happened in networking, computer communication, and wireless. There are two planes, a lower one, which is technology, and a higher one, which has to do with usage and applications. When the ARPANET got built, it was not to support email. So electronic mail came later and became a killer app. The web didn't exist, now it exists. Now we can talk about, I don't know, social networks and all these uses. At the technology level, it's always easy. We want more of the same. You know, scalability, larger networks, more nodes, more base stations, gigabit to the user. And we work on these, and sometimes we don't know if they are needed, but we say, provided, they will use it. But when applications decide what to do, they see that there is an opportunity, and they go and they build these things. If the bandwidth didn't support it, you work on the network to provide the bandwidth. You have then the incentive, the need to do so. So it's an iterative process. I don't know.
Yeah.
So talking about iterative processes, I want to add to what you just said, Fouad. You know, there was a time when technology raced ahead and applications followed, taking advantage of the technology that we all created. We've passed a tipping point now. The applications are ahead of the technology, and they're dragging the technology behind them. They want more bandwidth, they want more resilience, lower latency, and all the rest. So the table is turned in that respect. That's the additional comment. Mm-hmm. But the answer to your question, and relates to the first question you asked, is this: what was the vision? You know, we've had visions all along. In 1969, I have in writing a vision as to what this would all become. And I said this capability would be always available, always on, anybody with any device could get on at any time, and it would be invisible. Well, this is not invisible. This is the pain in the neck. It's wonderful. It's got tiny keyboards, different applications. Each one, you need to learn the protocol. It's not disappeared into the infrastructure, which we heard Mark Weiser say should be the case. It shouldn't be in your face. It should be soft and disappearing. And IoT is giving us the opportunity to make that happen, where we shouldn't have to be carrying devices. I should be able to interact with voice, Siri, or whatever, gestures, haptics.
Cortana.
Excuse me? I didn't.
Like Microsoft's Cortana is.
Oh,
It's better.
No. It's twice I said no today. But I think the ideal, and where I see this going, what we need is to get rid of the infrastructure in our face and put it into like electricity. We shouldn't have to worry about it. It should be there provided to us. And we should interact with it the way we interact among humans.
Agree 100%. It is not yet invisible. I got to Berkeley right as they were publishing the Smart Dust paper, which said we will paint the walls with sensors. You will not even know they're there. They might change colors. They might do all kinds of really cool things that we can't even imagine. In 2005, Jason Hill and Brett built a millimeter cubic full-on device with power, sensing, computing, communication. We're 11 years later. I don't see anybody in the marketplace doing that. Actually, when Andrew was like, so we picked your paper for this test of time thing, and I'm like, isn't Internet of Things like still a thing? So are you sure about this? Because there's still a ton of research to be done in the Internet of Things, and the hardware has not moved as fast as it certainly could have. Just that standards process has taken 12, 13 years. So that, and I like your tipping point analogy. Human-centered design has become sort of a really big thing over the last 10 years. So starting with user needs and not technology needs, I think to drive what are the important things that we build. There's one more thing we talked about at dinner, I don't know if anybody's gonna bring it up, but I thought it was really cool, which was how do we build a sustainable mobile device? So something that is either biodegradable or has no power source or is internally powered or is powered by the wireless, or I don't know how it would work. That's for all the smart people to figure out, but making technology sustainable so that as we go through cycles of devices, or we don't need to go through cycles of devices, that there's minimal to no environmental impact.
It's of course hard to predict 10 years out. I think one interesting thing stepping back and listening to all the test of time presentations is if you look over the last 30 or 40 years, we've seen radios, just for this audience, become a lot less precious, right? If you think about how many radios existed, packet radios in the world in the 70s and in the 80s, and then over time, it just has been going up by factors of 10. And whenever you see factors of 10 kind of change, everything gets reconsidered, right? The networking model, but also authentication, encryption, power consumption, form factor. So as we think about how many radios each of us interact with today, it's no longer just one. It's not our laptop, it's our smartphone. Some of us have fitness trackers, other watches. I wonder about 10 years from now when we have 30 or 50 radios on us, maybe heart rate sensors, maybe all kinds of other things we haven't really conceived of. That'll be an interesting future, and I don't think we've completely developed systems to deal with that kind of proliferation yet. So it'll be interesting to see what happens with that factor of 10 scaling or factor of 100 scaling.
So indeed, this IoT space likely to have a significant impact. Like first, we started with providing basic connectivity, and once we have reached a level where connectivity is no longer an issue, it's being able to sense the environment and being able to have the environment suit you.
Can I start and ask you why you would say connectivity, we have already solved connectivity?
I mean, I agree, like there are spaces where connectivity has not been addressed, but as at least to a larger extent, it has been addressed.
Just acknowledge the fact that we have privileged few or privileged billion, let's say, that have connectivity.
But even if you look at in developing countries, like more and more people are getting online. Maybe the rate is not at the same pace as we would like to, but it's happening. Now the next phase, maybe places which, just like in the case of landline to mobile, we saw that many places which didn't have landline connection were able to benefit much more from mobile connectivity. Maybe like IoT space can have the potential of impacting them more than us. But overall, it has the capability of affecting our lives in a big way, going beyond connectivity and changing our environment, both in the way we sense as well as we react to that.
It's one of the ones that's up on the list here, but if I was going to start a new lab and have a sort of 10-year agenda, it would absolutely be around building power harvesting and zero net energy systems. We're not going to reach Weiser's goal on his graph of hundreds of devices per person, or get to the point where something truly disappears until the devices are perpetual. You turn on the device and it harvests enough power to run forever. That should be the goal. Most people, have been following Moore's law for the last 20 years, and that, computers are getting faster and faster as the transistors shrink. But what most people don't realize is that the number of cycles per joule is also scaling exponentially. And what seemed crazy even 5 years ago now as a workload, you can run reasonable amounts of computing on microwatts now, and with duty cycling, we really are getting close to the point where we're going to build little nodes that we deploy and turn on, and then they run forever, and that's where we have to get. But it's not just something for sort of nerdy power harvesting antenna engineers. We as systems people need to think about it from top to bottom. I mean, you're going to be scheduling computing, and it's going to have a certain number of joules to actually run. So you actually adjust what you send and how you compute based on the amount of power. And the system's going to turn itself off and then potentially turn itself back on at some point. So you need to think about persistence and durability in very different ways. And I find this really, really fascinating.
I think of two problems. So one is agent-based computing. This was all the rage maybe 10, 20 years ago. Maybe the conditions today of more powerful devices, very well-connected devices is kind of going against that trend. But I have a feeling that just the concept of having a persona of a mobile user in the cloud is still a powerful concept. I would like to see that, or I'd like to work on that. And the second problem, as a problem for humanity, is it's hard to imagine being in a only single language culture in the United States, how difficult it is to understand other languages. And I keep asking my friend who works in Apple on speech recognition, oh, why doesn't Siri work in India? I mean, he says, well, because we keep switching from our language to English and then back again, and it doesn't know which speech model to load. I mean, such problems can be solved by throwing infinite computing, perhaps, that the cloud provides. But multilingual recognition, I'm hoping would help us understand other cultures better. And in this era of hate everything, hopefully it will bring more peaceful outcomes to the world.
Norm mentioned that, voice will be the main interface today. And somebody else said, we want all our devices to escape in the ether. No pun intended, the Ethernet will be back. So if that is true, even if you look at all the current rage about conversations, human conversations don't require any device. Two people can perfectly speak if they know the language and they seem to understand each other and be able to transfer information. Maybe that's the world we are getting into. So maybe we don't need any device. Either you talk to yourself or somehow you talk in the ether and you will get this information. I think we are getting there with all this tremendous amount of research that is being now done with much more conversational interface rather than a protocol-based interface. I think the next 10 years there'll be a lot of breakthroughs in this area.
So I don't know how much this will, whether this will actually be deployed in 10 years, but I certainly think it'll be part of the conversation. And this is going maybe a step beyond Len's point about the places not being ubiquitous enough yet in terms of devices. And that's, are persons ubiquitous enough in terms of devices? And where do we end up embedding sensors, with embedding sensors and control on our body, right? I mean, we have bracelets now and eyeglasses and rings. Will we have things embedded under the skin, on top of the skin, in all parts of our clothing? What will be the services and applications that are offered that would make it attractive enough for me to tolerate that sort of intrusion? I think that's a lot of good technical problems there as well as ethical problems.
So somehow I seem to have my own.
Is it working? You might want to use this.
Is it on? Okay, good, great. So I'm going to take a slightly different approach from what most of the people have talked about. I really think we should rethink some fundamental issues in mobile computing. So a long time ago, there was an actress, I forget her name, who had the famous quote, "In life, you can never be too rich or too thin." And in mobile computing, your mobile devices can never be too small, too light, or have too much battery life. So if you want a really aggressive agenda for a decade, imagine that the mobile devices 10 years from now are 10 times smaller and lighter, have 10 times the battery life, and yet the value they deliver to us is at least 10 times greater than what we have today. You know, how would we build such mobile computing systems? I think would be the kind of question that would drive us.
So thank you, everyone. Now you can go and write your thesis, PhD thesis on all these topics, probably. So we have one more question, and perhaps, depending on time, we'll see if we can get some more questions for the audience. This is more targeted somehow. It's one, I don't know, you can start from there. It's about really collaboration with other disciplines and interdisciplinarity in a way. It's about the fact that often we use other disciplines, so other computer science disciplines, knowledge and logic as a black box, and how we possibly could interact better with other communities, especially now with machine learning being one that is kind of pervasive everywhere. So interpret this question the way you like. You've seen it before. I sent it by email. Some views on this interaction. It doesn't need to be sequential. I mean, we've been doing, you're doing it too well. I didn't expect this tidiness in answering. And you can start. Yeah, want to be the cat? That's okay. No, we have some time. But
I don't need mine. It's okay. It's all right. I don't. Oh, okay. All right. Okay. Well, so I said about spectrum. So forget that for a second, because it seems like. Okay. So about this topic that you have, it's actually very real and fairly important, actually, both for students and just look at the world as it's moving. And I suspect that's how you're sort of seeing it. For example, just a couple days ago, or a few days ago, Satya Nadella, who is the CEO of Microsoft, gave a talk and said democratization of AI. And if you've been watching how the world is evolving, you would see that there's a lot of debate and discussion going on that AI is going to come and potentially take away jobs. An example is if you go to a local grocery store these days, how many of you are now seeing that there are automatic tellers and you just sort of scan your own thing and you take the grocery, and there are fewer jobs there, for example. And this will keep going on. And the problem now is that very, very few people will really understand how AI works, and so the power is now concentrated in certain areas. But all the companies are reacting to that, so they are, so for example, Microsoft just created a whole division called Microsoft AI, and about 5,000 people working on that stuff. And I'm sure Google has one, and I'm sure Facebook. In fact, Facebook has a lab called FAIR, or Facebook Artificial Intelligence Research. So what do you do in the context of all this stuff in the world that we work in? So I can just tell you how I approach this thing and what I'm doing. So I have a project now that I've been working for about 2.5 years now, and it's been sort of under wrap, but I'm starting to ready to come out now a little bit. And that's to sort of think about the end-to-end system that I want to build. So the system that I'm building essentially is all about video analytics, real-time video analytics, okay? So we've got cameras all over the world. They are watching everything, surveillance, security, for traffic, for example, congestion control, et cetera. But all the video comes back into this central place, and nobody ever looks at it till there's some issue with the video. And then they go back and look at it. So why can't we just build some real-time analytics system which will do and alert us at the time when the event is happening? Now, the problem is really hard. But one of the things that intersects with wireless and mobile is that these cameras, as we build the whole pipeline from static cameras all the way to the cloud and put AI into it, for example, and put all this machine intelligence into it, we realized that another event was happening, that the wearable cameras were taken off, all this stuff happening in the crime with police officers wearing it. And then I also found, talking to a company, that they want systems like when you take a gun out of your badge, there's a sensor that will immediately alert the headquarters that a gun has been taken out of the holster. And then so now they know that a very serious event is happening and they would like to dispatch or do something more. So the thing is that as you see these problems in real life, these problems actually exist, and the pieces of the technologies already exist. But again, the thing is, how do you get them to the masses? And then the way you get them, then you start to see every piece breaking. You see the vision algorithms breaking. You see the network, because these guys are mobile, right? They are sort of pushing the data out. You see the bandwidth is not there, no matter what we've heard here about connectivity. Then you see, okay, where do you perform? The edge, you have to perform the computing at the edge because the latency to the cloud is not fixed. So as you sort of go by, you see many, many problems. So I guess the bottom line of what I'm saying is that there is no lack of problems. You just need to observe real life of what is happening. And even as we build more technologies, more problems emerge with each of the technology we build. And from there, as if you become good at observing and you're good at watching how people are behaving, you will find so many problems that you just will not have any time to work on it. So I don't want to monopolize this, but that's sort of, I didn't want to say the thing. I actually do want people to work on spectrum availability. I think that is very core too, because there are billions of people not connected. I know, I've seen those people, and I've got mail from people in Africa that this white space changed this guy's life. And so that impact, unless you feel it, you'll just keep working on the new shiny object that you see. That's it.
It's hard to follow that. Well done. So I'm going to take a different tack. I see we're talking about some AI and machine learning, and I haven't heard the word biology mentioned today, except perhaps with the fitness devices. And in terms of frontiers, if I were to start over again, I'd work in bioengineering. I think there's enormous, rich problems to be studied there. Wide open, low-hanging fruit, unmined areas, places to look. So that's one dimension. But the other thought I wanted to offer is that in these complex systems, and they are complex, you always have to look for simplicity. Dumb it down to make it simpler and simpler so you can absorb what it is you're investigating and not some complicated result that you can't even understand. Simplify it, use symmetry, basically turn the problem around and look at the solution and what problems it's solving. There are many techniques for the researchers in this audience in the domains we're talking about that require high-level thinking instead of getting down into the trenches and getting stuck trying to deliver 2 bits per second out of the foxhole. That's a small problem. Think big, challenging.
So I actually want to flip this around. I completely agree with the premise of the statement here, which is indeed some of the most valuable breakthroughs, insights come at the boundaries between areas or disciplines. But it also comes with significant risk. Any program committee that you submit your work to, whether it's for a paper or a funding proposal, is typically drawn from an existing area of concentration. And in the eyes of that group, the reaction is very often, oh, this might be good in the other area, but it's not a big enough result in our area. And in this way, it is very easy for interdisciplinary work to be disparaged and lost. And it's a very real hurdle and a challenge to overcome. I'd love to hear if any of my distinguished colleagues here has experience, ideas on what one can do to reduce this, minimize this. And in fact, I completely agree with Len's point about simplicity, but that simplicity is somehow also turned around and viewed as naivete by people who are steeped in a certain discipline.
You said less astute. They're not thinking. Oh. I'm done. I said it. You can keep it. Keep it simple.
Yeah. Sorry. This is good. No, that's okay. We got, that's for you. That's for you. So
in the middle, Anthony.
So Satya, here's the. I think your point is correct. I'll tell you, I don't care. That's how I deal with it. I have stopped caring so much about the fact that my paper gets into SOSP or MobiCom or you name it. That is the secondary problem for me as I go after this. I understand that from a student's perspective, you have to sort of think, be a little bit more strategic about it. But I would just say that, you do the great work and figure out wherever the heck it gets published, you find a place to publish it. It's just, we are in silo. You're right. We are siloed. We are not that interdisciplinary, even though we talk about it. But what the heck, we got to keep moving forward, and that's what I think. I stopped caring as much.
So there are other individuals, namely the students who are involved.
Yeah, I did say that, yeah, that is
So my reaction to this is rejecting the premise of the question. if your usual approach is to treat someone else's capabilities like a black box and expect them to treat yours like a black box, then don't enter that collaboration, right? You need to bridge the gap more. You need to define shared goals that you both try and understand how your various expertises can help and meet in the middle, not just say, oh, well, you're doing that bit. I mean, maybe if you do that, then you could target one paper at one conference and one paper at the other conference and keep it nicely down the middle and get your paper out. But you won't be getting the Test of Time award. You won't be proud of that research 10 years on as something that defines, a really great thing you've done, whereas you will be if you take that time to work across disciplines more closely.
Maybe a simple-minded way of talking about this is layering in networks. We have isolated one function from the other with layering, and that made it easier for us to deal with things. But where we found the need to do cross-layer design, we did. So I would see AI more pertaining to the application and where communications is a need, and we may be able to satisfy it. But where we see interactions between these two, like between layers, then by all means we should leverage that and take advantage of it. Most of the good work happened because two different disciplines, maybe in the same, technical area, electrical engineering or computer science or whatever, were leveraged to get things that are really salient and good. So.
If you don't have any pressing comments on this, I would like to see if the audience has some, I think I can see already an audience person
it's
who
actually,
has some questions.
So it's actually relevant to this question. That's
okay, yeah, that's fine, Robin.
We had a long discussion about this during the workshop that Suman was talking about, Robin Kravitz, University of Illinois. And this came out of the fact that there are people in the AI and the machine learning and the data mining community, and they are treating all of the systems and all of the networks like black boxes because we, as two communities, have not been able to bridge it. And it's not that, we shouldn't do that. It's that we haven't been able to bridge that. If I talk to the people in my department who are doing machine learning, they don't care that the network costs. They don't care that the connection is miserable. They don't care that there's power limited. They just assume that it's basically a network like any other network and go from there. So it's a challenge to us as a community at this point where we've built so much and designed so many solutions to push that up so that they understand that they can't treat the world like a wired network, or they can't treat the world like a cloud system. That if they want to do sensing and they want to collect data from sensing systems, it's not just going to be, oh, I want that data and I can have it. So I think that's kind of where this question came from, and I'm not sure that's how it was taken by the panel. So.
Well, Robin, that's an excellent observation. We're black boxes to them and they're black boxes to us, which is a terrible situation.
Yes.
For example, if they recognize that broadcast communications that we're talking about here has a terrific advantage in some algorithms that they may be running. If they assume it's just wire-to-wire, point-to-point communication, they'll lose an enormous opportunity. There's gold out there to be mined. So I think opening up those boxes and understanding how each other's domains work, because machine learning is a whole other field. It's wide open, it's complicated, it was dead for 20 years, it's come back. Thanks to Minsky, by the way. But I want to get to one other point, and you began to address it, Satya. Many of the folks here are students, and you have enormous pressure on you to be able to publish a paper in a siloed journal, as opposed to what you said, and I empathize with what you said. I think a bigger crime is you being forced to publish before you're ready to. Little papers are coming out of little significance just to get the numbers up. And I think that's a terribly unfair pressure, and I'm speaking as a faculty member, to the students who are just learning how to do research. I like to say, I've told some of you already, that I consider the PhD research work number 0. and move on from there. But you shouldn't have to be putting out little tidbits to increase your resume. On the other hand, that's the situation now. And unless we collectively change it, and I don't see how we do collectively change it, all at once, synchronization, okay, no papers required of young students. But that's a problem.
James, do you want to say something before we get?
I'd actually, I want to add something
Yes,
to that, because something that didn't come up, which I'm surprised, is to sort of look at what do these papers have in common. And I think they actually share a number of things in common, like simple solutions that address real problems. But the thing that I really took away, especially with the last 3-4 talks, was just the huge amount of work that actually was involved on the part of the graduate students. I know we did, I want to say thousands of hours of driving and measuring. We drove every single public street in Seattle. You have a 40-foot ladder. And I know what you guys did on Great Duck Island. Just enormous amounts of work. And you just can't do that if you're expected to produce 3 papers a year. 3 grad students should be able to go off and do good work for 3 or 4 years and then come out with a major result that's actually going to be up here on the stage. So I think, yeah, a lot of time is required for these top results.
That goes to answer the first question as well, in a way. It's an answer again to what makes a good test of time.
One thing I would say to Robin, that there is a lot of work, by the way, going on in networking to use AI to do, for example, network diagnosis. Right? Data-driven networking and big data networking is actually happening. It's not happening in this community. But as you know, I actually work and manage a group all in cloud as well and networking there. And there's a lot of intersection between AI and. So what is not happening, I think, is that AI thinking of what can we do in the network. Now, even there, I would say there's a lot of work because all these big data systems, for example, Hadoop is an example, or any of the MapReduce systems that you take, we are building them to be much more efficient to do AI sort of work. So I think you're right in the sense there is silos, but I do believe, I can tell you from industry side that the silos don't exist as much as they exist in academia. I can also tell you that the way academics think about AI is very different from the way industry thinks of AI. For example, Bing is considered like an AI thing because now they have a notion of knowledge graph inside the search engine, which is not looking for links like you have been used to, but actually looking for actionable items. So when you talk to Cortana, for example, you know that you need an answer back. And so a lot of work is going on. And then how do you speed it up? The infrastructure for speeding it up, that's all networking infrastructure. And so those people are absolutely talking. So I would actually submit to you guys that academia, and I'm going to say a provocative statement here, that you guys are a little behind the times here in terms of what is happening in the real, in the world that's industry world, I guess.
Okay, we'll take one more question from Suman.
Okay. I know Andrew had a question.
Well,
too.
we have less than 10 minutes.
Okay.
So, yeah.
I wanted to start with a very small observation.
Make it quick.
Okay. Seeing this very distinguished group trying to share 2 microphones, I thought resource sharing is still an open problem. But that's not my question. My question is, if you wanted to advise this community, what are the problems we should not be working on, or we are wasting on our time working on that problem, what would they be? Because if you look
and note that we can't predict, so I would write those down and work on them.
So, I would advise this community to work on mobile communications and be very careful about jumping into thinking, oh, you know what, we can do something wearables, without first talking a lot to the wearables community, because there are communities who do that sort of thing, right? So, going to the conferences, steeping yourself in that community as well, and then by all means, definitely joining up. But, I would advise this community to not just go, oh, let's try something over there, without taking the time to get the background in that you did when you did first work in mobile communications first. So.
Any more non-topics? No, you don't want to exclude anything. Okay, I think Andrew really wants to ask another question. Oh, no, so there's another one.
I'll say something.
We'll take this one.
Do not do incremental work, where you have a graph that's just a millimeter. Oh, I'm sorry. Do not do incremental work. Maybe think different. Seek to want to do something that's kind of different, if possible.
that goes back to being able to do sizable work and publish less as well.
Yeah, answering Suman's question, what not to do, is a little incremental work.
Yeah,
Because you can keep busy and then your time is wasted on doing things that did not.
Don't do signal strength-based location.
I mean, right.
It's never been a good idea.
No, actually do it. The citation count keeps going up. Good job. Keep doing it.
Last question from the chair of this.
Okay. I'm so thrilled that we've actually got 5 minutes left.
I have 5.
So I'm gonna ask the last question, Cecilia, and then I'm going to thank you, Cecilia, and then Marco is going to talk about the event tonight. So this is a completely different question, but I know you have sort of passionate views about this, and I'm interested in your thoughts about how to solve this problem, and it's a really difficult problem. Imagine 20 years from now, and there are actually 11 women sitting on the stage here, and a male moderator. What do you think it will take to do that? You know, I'm not talking about generally society, I'm talking about computer science, EE, I'm talking about universities or in tech, Google, Microsoft, whatever, Facebook. What will it take, in your mind, to bring forward, you know, the sort of creative power of women and have them publish papers and their papers be accepted as test of time?
Can I take the question? I went on Saturday, I was at a wearable and fashion workshop, and I had to, for my first time, I had to queue for the toilet. I never queue for the toilet in this kind of communities. I just rush through and I'm the first, and then I see all the men queuing. So yes, we should do more application and more arts, and they will come flocking.
I have a couple thoughts on that. I don't actually work in this community anymore. I work at a startup in San Francisco. Diversity is kind of a big problem there right now. And I think there's a couple things that need to change. I think we need to change the way we do graduate student admissions. I think we need to change the way we do faculty hiring. And I think we need to reduce unconscious and conscious bias in the community. And those would be the places that I would start, is really just overhauling the way that we determine and sort of qualify candidates. The other thing is, like, I think we oftentimes talk about solutions, you know, do another routing layer, do another MAC layer, and we could talk a lot more about problems, opportunities, visions, missions that we want to accomplish. And I think those kind of things would help to just make it a more fair playing field than traditionally this industry, which has been around a long time, has been.
I think it begins well below university level, like elementary school, nursery school, where the biases begin to expose themselves. You know, I'm not a social worker, but I have a wife who is, and she makes it very clear what goes on in her life and the lives of our daughters. It's been a real problem, and us guys up here, we can't appreciate what kinds of influences and subtle signals are passed to women from the time they begin toddling. I don't have a solution, but I recognize the problem. But here we are. It's excellent observation, guys.
I don't have a solution either. But what I do want to acknowledge is that if half of the people on stage, for much that the work represented here is fantastic, I strongly believe, and I'm sure you do and many other people do, if half the people on this stage were women, the work would be even better, by far. So we need to try and find a way to do that. I don't have the solution.
Okay, let me tell you a couple things that we are doing. So, but let me recognize the fact that Len said. I run a Washington statewide middle school computer science competition. I've been running it for now 2 years, 2 or 3, this is going to be the 3rd year. And so now think about what I'm going to say, which is that there were, like last year, there were 190 students who participated in that competition. Out of that, there were 33 girls. This is middle school competition, computer science. So even at that level, you're seeing that we are not getting, so this is a very, very serious fundamental problem I mean, if the pipe is going to be so thin, no matter what you do, it's not going to sort of like, produce the 50% that we should get, right? So Len is right. It is a fundamental social problem. And yes, what we can do, for example, in Microsoft, one of the things we have done is we've sort of internalized this. We are going to make sure that the number of women and the men that we interview is equal. So we are not saying hire, because we also, I am very cognizant about reverse biases too, which is sort of like, and I've seen that happen as well, which is where, it just sort of turns out that you're really, in some sense, after intellectual honesty, and then you do a reverse bias. So, but what we want to do is remove these other biases that you talked about. And so we're making sure that the data that is presented to everybody else and that the coaching to every individual is to be aware that they have these reverse biases. So it's going to take time. I do see some positives here because I see, for example, Harvey Mudd has more women now graduating. I know UW has got some massive percentage of women who are now enrolled in computer science. I do think Stanford still has a problem because I was told that in Stanford, 50% of the graduate women will leave the school before they graduate. So what the heck is happening in the school that 50% get into the grad school, but they don't graduate? If you talk to industry, if you're not even getting the resumes, where the heck are we going to hire from? So really, honestly, as parents, maybe, as family, as society, we need to kind of go in and recognize that you got to get to the elementary schools, as Len said, middle school, and just start to increase the pipeline from that point on. So it's a serious problem, but 20 years, I think we can do this. 10, 20 years, we absolutely can do it, and shame on us if we don't do it, I think.
On this note, I completely agree. On this note, I see Marco walking here up and down, so I will thank all the speakers, and please join me, and thanks for your papers.